The topic is solving homogeneous Cauchy Euler equation using variation of parameters to find a particular solution. So here's the method of solution. If a Cauchy Euler equation has this form, then first we need to find the complementary function, which is set for the homogeneous equation. And then we have to put the equation into standard form. And once we do that, we're going to find the complementary function. Now, once we do that, we're going to let's assume the complementary function is c1y1 plus c2y2. Then we're going to assume yp is u1y1 plus u2y2. And then u1 prime will have this form, and then such that the w is this, the w1 is that, and the w2 is this. Alright, so let's do this example. So let's solve the Cauchy Euler equation 3x squared y double prime minus 2x y prime minus 2y equals 0. So first, equal x to the 4. We need to do the homogeneous one. Right, so this is what we're trying to solve. So we're right here. So first we need to set it to solve the homogeneous one. In other words, we need to solve 3x squared y double prime minus 2xy prime minus 2y equals 0. So how do we do that? We need the characteristic equation, which is right here. So m minus 1, a is 3. So 3m m minus 1 plus bm, b is negative 2, so minus 2m plus c, which is minus 2, so minus 2 equals 0. So let's distribute 3m squared minus 3m minus 2m minus 2 is 0. So 3m squared minus 5m negative 2 is equal to 0. So we can factor this one. If we factor it, we'll get 3m plus 1, m minus 2 is 0, which means m1 is equal to negative 1/3, m2 is equal to 2. So the complementary will be x2 m1, c1x m1 plus c2x m2. So the complementary function is c1x, m1 is negative 1/3, plus c2x, m2 is 2. So we did find the complementary function. Now we're right here. So first, we need to do this. We need to put the equation into the standard form so we know what is f of x. So we need to divide. Here's the equation, the homogeneous one. We need to divide by 3x squared to get rid of this 3x squared. If we do that, let me do it in two steps. 3x squared y double prime minus 2x y prime minus 2y equal x4. We divide by 3x squared, 3x squared, 3x squared, and then 3x squared. If we do that, we'll get y double prime minus 2 over 3x y prime minus 2 over 3x squared y, which is equal 1 over 3 x squared. So my f of x is equal 1 over 3 x squared. Next thing, we need to find the y1 and y2. So since this is yc, I'm going to pick this to be my y1 and my y2. I need a fundamental set of solutions. And I'm going to assume that yp is equal u1 times y1. In our case, it's plus u2 times y2. And we know that y1, let me write it here, y1 is x to negative 1 over 3 y2 is x squared. So now, next thing we need to find the w. We're right here. W by definition is going to be y1, y2. So x negative 1/3 y1, x squared is y2, and then their derivative. Derivative will be next 1 over 3x. Negative 1 over 3 minus 1 is minus 4 over 3, and then this is 2x, which is equal to 2x. 1 minus 1/3 is 2/3. I'm multiplying these, and then minus, multiply these. Minus minus is plus 1 over 3x. Negative 4/3 plus 2 is 2/3. So this is equal to 2 plus 1/3 is 6 plus 1. 6 plus 1 is 7 over 3x 2/3. Now again, I'm right here, I need to find the W1 and then W2. For the W1, we need to start with 0 and f of x. My f of x happens to be, here's my f of x. One over 3x squared. And then I'm going to write x squared 2x. Now if I multiply this together, I get 1 over 3x4 minus 0, which is 1 over 3x4. Then y2 is the other way around. I need to write a 0 here and f of x there. And then my y1, so x negative 1/3. So x negative 1/3, and its derivative, which is minus 1 over 3x negative 4/3. Now if I multiply this, I get 0 minus, then it's 1 over 3x 2 minus third. So 5/3. Now u1 prime is equal w1 over w, and then u2 prime is equal w2 over w by definition. So w1 is right there, and remember w, we got 7 over 3x 2/3. So 1 over 3 divided by 7/3 will be 1 over 7. And then 4 minus 2/3 is 10 over 3. Now u2 prime is w2, which is right here. It is negative 1 over 3x 5 over 3 divided by w, which is same thing, 7 over 3x 2/3. Now this is equal, if you divide you get 3 there, so minus 1 over 7, and then 5/3 minus 2/3 is 3 over 3, which is just x. Now by definition, so since we have u1 prime, u1 is just the integral of u1 prime dx, which is integral of 1 over 7 x 10/3 dx, which is 1 over 7 10 over 3 plus 1, 10 over 3 plus 3 over 3, 13 over 3 divided by 13 over 3 is multiplied by 3 over 13, which is 3 over 70, 80, 91 x 13 over 3. Now what about the u2? u2 is the integral of u2 prime dx, which is integral of negative 17x dx. It's negative 17x squared over 2, which is negative 1 over 14x squared. We're almost done. We said yp is equal u1 y1 plus u2 y2. That means yp is equal u1 y1. y1 we said, I forgot y1. y1 is x negative third x squared. X negative third, and then y2 is x squared. So yp will be equal u1, so x negative 1/3 times the u1, where is the u1? 3 over 91x, 13 over 3, plus y2 is x squared times u2 is right here, negative 1 over 14 x squared. So yp is equal 3 over 91 x, and negative 1/3 plus 13 over 3 is 12 over 3, which is 4, and then minus 1 over 14 x 2 times 2 plus 2 is 4. So this is the yp. Now y is equal to yc plus yp. Now remember, yc is c1x negative 1/3 plus c2x squared, and then plus yp, which is right here, 3 over 91x4 minus 1 over 14x to the 4th, and that's it for this example.